Okay, so one of the most interesting challenges for volcanology is to be able to forecast when eruptions will happen and the impacts of the eruption, as well as for an ongoing eruption when it may end. And there are many cases around the world today where these are not theoretical problems, but these are practical problems. And it's a combination of both science and science communication, because it's one thing to understand scientifically what might be happening, but often the challenge is helping a local community to manage that situation and to be fully prepared for an evacuation or another response if it's justified in case of an increase in activity. So there's a double world really. One is a scientific world and one is a science communication world. And this requires a combination of skills which are usually beyond pure physical sciences and more into social sciences. And in volcanology, it's a very interesting subject because we have to work across disciplines, both between physical sciences, social sciences, and working obviously with policymakers who in the end are the ones who make the final decisions on what to do with their populations. There are two recent cases which I'd highlight. One is in Tenerife, when there was exercises to prepare the local populations for the potential future eruption. And this is really important because it's very often the case that if the repose time between eruptions is longer than the lifetime of most people who live there, then there is just a memory issue that people forget. People don't recognize that they're on a risky volcanic site. And so it's imperative that physical scientists who study volcanoes can give people the facts of the reality of what problems may be produced by the active volcano, and then policymakers and social scientists can then help to prepare a community for what might be able to happen. And also having things like evacuation plans and where to go, what to do, clearly in mind, so that people are aware of the fact that this isn't going to come out of the blue, that people already have a knowledge that they are exposed to a significant volcanic risk. One of the areas which I think is most fascinating at the moment in the world is the area near the town of Naples in the middle of Italy, the west coast of Italy, which has two major volcanoes, Vesuvius, which is obviously famous for the AD 79 devastating eruptions, but also Campi Flegrei, a little bit to the west of the town, west of Vesuvius, which is a very active volcanic center. And that has, for many decades now, been showing increasing signs of unrest. And when I say unrest, what I mean is the ground deformation is swelling. There is growth of the level of land. There's huge earthquakes, many frequent earthquakes, felt earthquakes, and increased amount of volcanic degassing from the main area. And unrest has been seen in the 80s when there was a big increase in the height of the land around the volcano. But now we're in a state where this is even more. And what's remarkable is the unrest has become so persistent for so long that while in Manchester, if we were experiencing out of the blue such a type of activity, everyone would be absolutely petrified and probably self-evacuating, if I'm honest. But because the local people have got somewhat used to a background level of activity which is remarkably strong, people keep on going. And this creates a major challenge because we hope that there would be a long precursory stage to any eventual eruption because it would have to have a very sharp increase in activity from the high baseline it already has to make things strong enough for people to realize they really do have to move. Obviously, in the Naples environment, scientists are fully aware of the risks involved, and the population is very well informed through numerous activities by the local authorities, including civil protection in Italy is a key factor in that. So people are doing the best job they possibly can. The reality is, though, that there could be limits where as you approach a volcanic eruption, the unrest just keeps on increasing softly and then accelerates very quickly at the end towards an eruption. And then it's a question of how long that acceleration phase is before the eruption begins. And we hope it would be at least 24 hours. But there's always a possibility it's shorter, it may be longer. The fact is, we haven't seen Campi Flegrei do a major eruption in the past, and so it will be a potential challenge, and there's a lot of optimism that it will behave properly, but there's always a chance it doesn't. One of the things that we do for our research here in Manchester is we try to understand how to forecast volcanic activity. And we've been working on that very intensively because we can see that it's one of those areas where physical sciences and working in using complicated tools and lots of complex approaches actually translates from complexity into simple, useful policy-making outcomes. And that's really what motivates me to do the research I do. One of the key areas that we found recently, and we've done some recent work on this in collaboration with many colleagues, is to examine when volcanic eruptions will end. And what we do is we examine how much gas is coming out during an eruption, and we can see quite simple and distinct patterns where basically the rate of degassing decreases in a systematic fashion, which allows us from quite early in the eruption to forecast when it's likely to end. And this has been successfully done on a recent eruption in the Canary Islands in La Palma in 2021. And we're hopeful that this will help to do future forecasts of eruption endings. But there's some more recent work as well that we've been working on, which is extremely exciting, where we're trying to forecast when eruptions might begin. And this, we think, is particularly useful for persistently active volcanoes. And what we're realizing is that very careful taking account of the overall amount of gas being released over a long period of time, small deviations in that act like a sort of bank balance. And if there's a deficit, that builds up over time and then could be the trigger after a certain point, which triggers a new eruption. So measuring these deficits and excesses is a very powerful way, potentially, of forecasting eruptions, which hitherto is still beyond us. And perhaps to conclude, what I'd say is, really, the wonderful thing about earth sciences, and volcanology in particular, is the fact that we still have lots and lots of things to learn about the planet. It's not the case that because there's lots of books being written and when you're at school or university, people appear very knowledgeable and they know everything. We know so little about how the planet works. We still know very little, and it's a complex, interesting planet. And the solar system and the universe is a complex and interesting solar system and universe. And really, it is the case that hard work and interesting questions, asking strong questions, can still yield new insights into how the planet works, and that can go directly to helping in situations like predicting and forecasting volcanic eruptions. So if any of you are watching this who are thinking of doing careers in science, I strongly support you in doing that because it's a very exciting thing to do and you can really make a difference.